Good day, everyone. We are from G15, and our topic is home automation. So our group members are Bill, Hansen, David, Chin Julian, Tan Zhe Yi, and me, Guang Hetong. I will be the first presenter in the presentation. So I will start now. Background of the home automation. The automated control of technological gadgets in our house is referred as home automation. These gadgets are internet connected and can be managed remotely. Home automation system often connect control devices to a central smart home hub, which is sometimes called a gateway. And the system's user interface can be wall-mounted terminal, a tablet or desktop computer, a mobile phone application, or a web interface that can be accessed remotely over the internet. Home automation offers enormous for transferring data between family members or trusted individuals, which is for the personal protection, and it might eventually lead to energy-saving measures that benefit the environment. So I will talk about the history of the home automation. The original smart home were the concepts rather than physical construction. For decades, science fiction has delved into the concept of home automation. For example, in the year 1901 to 1920, the innovation of household appliance took place. For example, in the year 1901, the engine-powered vacuum cleaner was created. But a more practical electric vacuum cleaner was created in the year 1907. Not only that, but the Echo 4 and the kitchen computer were designed in the year 1966 and 1967 respectively. Also, in the year 1991, Geron technology was created, which is to improve the life of the older adults simpler. 1998 to the early 2000, the home automation became increasingly popular. So now I will talk about the current trend. So in the recent decades, smart home automation are more about security and living greener. So one of the top smart trend is touchless tech. This trend has already begun to pervade the smart home market before the COVID-19 epidemic in 2020 and 2021. We have probably seen touchless hand sanitizer dispensers in retail settings or in the shopping center. Well, they are not likely smart enabled, but the possibility is there. And the touchless notion is growing. For example, touchless doorbells allow guests to announce their presence without touching a common surface. And the second one is smart thermostat, which is have become one of the most commonly accepted smart home tech products after the smart speakers. They are usually easily to set up and fully adjustable to the temperature and the heavy switches. And it allows us to easily change the climate in our home from anywhere. And the third one is health tech, which is one of the current trends that was accelerated by the pandemic. For example, smart air purifiers and air conditioners are on the increase to help improve and sustain the air quality throughout this worldwide health crisis. And the fourth one is home office. We can, like, for example, from the noise cancelling windows to shutting our neighbors, to artificial intelligence filters that cover up a dingy living room while we are on a video conference with our boss. And this technology will be the tips of the iceberg. So now I will talk about the future trend. And smart home automation is becoming more popular by the day, and it will be the fundamental prerequisite for future homes that are smart enough to give the best possible comfort to people. And this technology has several features. And the first one is smart houses. Smart houses such as Google Home, Amazon Echo will make it simple to control the smart gadgets placed in the IoT connected homes, such as using camera, door speaker, mic, door locks, and they will be or can be controlled via the smartphones. The second one is a smart light. Smart light we can use, like for example, we already on the bed but be lazy to turn on or off the light, so we can control via our smartphone. The third one is smart air conditioners and the televisions. For the smart air conditioner, we can adjust the temperature based on the time surrounding, like the outdoor temperature or the amount of the people present. So the fourth one is the virtual experiences. like reordering things, meeting, partying, and working will become less physically taxing and may be done remotely from our smart homes. So that's all for my part. I will pass to the next presenter. Thank you.
My name is Chin Huyan. So now I will be presenting about the problem statement of home automation system. So the first problem statement is home security. Some of the people may leave their home, leaving all their home appliances without any kind of monitoring and control. Some home appliances are left plugged into power socket, whereas some of the power appliances are plugged in or out of power socket depending on the user uses the appliances or not. So all of these action needed people manually attend to every appliances independently from time to time. Then for the second problem statement is emergency situation. An emergency situation may happen that needed to be controlled when people are not at their home. For example, people went out of their home and forgot to lock the door. Then people can use this system to lock the door through the application or website. So users do not need to worry about their home security and so on. For the third problem statement is conveniences. User can monitor and control their home based on the situation that are connected to the system or application that we have created. Next. So now I will present about the objective of our project. The objective of our project is to develop a home automation system with voice command that perform all basic functions of a virtual assistant that inform temperature and control home appliances that are connected to the system. So for the problem statement, we also have the proposed solution for it. In this project, we will use Amazon Web Service, which means AWS, as the development tool to develop a home appliances system for user. So the system we provide will help user to control and monitor their home, such as temperature of the home appliances, door, curtains, and others. Besides, we also will use a controller and Alexa that can help user type the command or use voice command to control the home. User can monitor their home situation through the dashboard we have provided. Moreover, after all the information about the home appliances and situation is uploaded to a cloud that we have created, it will help users to visualize the information about their home that has already been uploaded to the cloud. User can control their home since we are already visualize the home situation, home appliances and situation for them. So I will pass to the next presenter.
Okay, I'm Tanjai. So now I'm going to present the proposed solution of our assignment. So I'm going to briefly explain each component. First, I will explain the controller. Controller is used to control home automation equipment and ingest data to AWS IoT Core. Then AWS IoT Core is to collect data at scale and route message to multiple AWS service. The next one is AWS Lambda. It's called inside the AWS IoT Core statement to transform the incoming data prior to ingestion. The next one will be Amazon TimeStream. Amazon TimeStream store time series data and optimize it for fast analytical queries. The next will be AWS IoT Sitewise. AWS IoT Sitewise model and store data from equipment for large-scale deployment. The next will be Grafana. Grafana is installed on EC2, AWS EC2, visualize data in near real-time using interactive dashboard. The last one will be Alexa Skill Kits. It's allowed interaction with device using voice command. So I'm now going to explain the solution overview. The step one will be ingest data to IoT, AWS IoT. The IoT-enabled controller provides the out-of-box capability to send data to AWS IoT Core service. So the second step will be store data in TimeStream or AWS IoT Sitewise. The ingested data is saved for historical analysis. TimeStream is a serverless TimeStream database server that is optimized for high throughput ingestion and has built-in analytical function. It is one of the options you can use to store IoT data. Time series is a common data format to observe how things are changing over time, and it is suitable for building IoT application. The third step will be visualize data in Grafana dashboard. Once data is stored, it can be made available to multiple applications. Grafana is a data visualization platform that you can use to monitor data. It supports near real-time visualization with a refresh rate of 5 seconds or higher. You can visualize data from multiple AWS sources and other data sources with a single Grafana dashboard. Grafana can be installed on Amazon Linux system, Windows, Mac OS, or deployed on Kubernetes. Then the last step will be control using Alexa. Using the Alexa skill kits, you can build voice skills to be used on device enabled by Alexa globally. Alexa and AWS IoT enable you to create an end-to-end voice control experience without using any additional hardware. Instead, your function runs on the cloud only when you invoke Alexa with voice command. So that's all for our proposed solution. Okay, next I'm going to present a study of different IoT platform. The Internet of Things, IoT, is designed to remotely link objects for smooth operation and ease of use. IoT platform connect device sensor with data network. It provides information about data use in back-end application. An IoT platform is a set of components that enable developer to distribute program, collect data remotely, communicate securely, and manage sensor. IoT platform maintain device connectivity and enable developer to create new mobile application, new software application. It simplify the collection of data from device and drive business change. It connect multiple components and ensure a continuous flow of communication between devices. IoT platform help to better understand customer needs and facilitate the development of solutions to meet those needs. It provides company with more intelligence and visibility into their operation, leading to improved decision making. Since there are so many IoT platforms available today, a comparison was made to explain their technology. That's all for my part. Thank you.
Hello, my name is Bill Hansen David, and I will be comparing the AWS IoT to some of the competing platforms, namely the Google Cloud and Microsoft Azure Cloud platforms. First, we will take a look at the core IoT service for each platform. For AWS, they have AWS IoT Core. For Google, it is the Google Cloud IoT Core. And for Microsoft, they have two products offered as a core service, and that is the Azure IoT Central and Azure IoT Hub. Next, we will take a look at each platform's approach in providing IoT solution development. For AWS, their IoT solution is built around their IoT Core as the central component. So the AWS IoT Core functions sort of like a gateway for connecting IoT devices to the cloud. IoT Core is designed to integrate with other AWS services in order to implement a complete IoT solution. IoT Core provides a bridge for communication between connected IoT devices and various AWS services. Next, we have Google Cloud, which also adopts a similar approach. The Google Cloud IoT Core acts as the core component for the IoT infrastructure, integrating with other Google Cloud services which communicate with connected IoT devices. As a core component, IoT Core is packed with various fundamental features such as device management, providing secure communication channels, device and data security, etc. And then we have Microsoft Azure that offers a slightly more flexible approach. Firstly, there is the Azure IoT Central, which is a ready-made environment for quickly deploying IoT applications. IoT Central has various built-in functionalities and is well suited for deploying small-scale, simple IoT solutions. However, there is also Azure IoT Hub, which serves a similar function such as AWS and Google's IoT Core, allowing development for more complex IoT solutions. Additionally, IoT Hub can also integrate with IoT Central to further extend their functionalities. Next, we will compare each platform's offerings for IoT-specific services. For AWS, they have very rich offerings for IoT-specific services, the most among the three platforms. Here are among the many services which AWS lists under their IoT services category. As for Google, they provide significantly less offerings for IoT-specific services, listing only one service, which is IoT Core, under its IoT services category. Microsoft Azure, however, offers substantially more IoT-specific services. Listed here are some of them, although it is still way less compared to what AWS offers. And lastly, we'll look at the strong points for each cloud platform. Now, AWS undeniably offers the most flexibility as they have the largest library of cloud services to offer. AWS's system has matured well over the years with a long record of reliable services, appealing as ideal to large corporations. AWS IoT makes it suitable to build IoT solutions of any size and nature. And next, we have Google with a strong specialization for big data and analytics. Many of Google's services are data-driven, which makes it more suitable for building IoT solutions with emphasis on big data. And then lastly, there is Microsoft Azure. Azure allows seamless integration with many existing Microsoft services, which is very beneficial to many, given how widely adopted Microsoft's products are. They also possess the best-in-class AI and machine learning technology, with their many services more geared towards developing industry-level IoT solutions. And that is all for the technologies comparison. Thank you.
My name is Chin Hyun. So to implement the proposal solution, we are using the AWS console. Now I will be present about the AWS Alexa skill kit. So the first step is we need to create an IAM role for Lambda. So first step is to navigate to server, then click on IAM, click on the roles, then create role. Second is select the trusted entity types, then we click on AWS service. After we click on the AWS service, we need to choose about the use case, then the use case is for the Lambda. Then we click the next button. After click the next button, we need to tick the box for AWS Lambda basic execution role. Then we click on next button. We will go to the, we need to enter the role name, which called AWS Lambda Basic Execution Role Smart Home. Then we need to create the role. Finish create the AWS Lambda, so we need to create another Lambda function. Also the same with the previous step is we need to navigate to the service, then click on Lambda, go to function, create the function. So after that, we need to select the author from scratch. Then we need to configure information that below of it, which is function name. We type as turn on light. Runtime, we type Python 3.6, 3.7, or 3.8. Execution rule, we choose the use an existing rule. So the existing rule, we type the AWS Lambda basic execution rule, smart home. So we click on the create function button. So after we create the function, we need to configure it. So same with the previous one, we need to navigate to server, then go to Lambda and go to the functions. Then we need to find the Lambda we have created, which called turn on light, to open the function page and click add trigger. So from the trigger configuration drop-down menu, we need to select Alexa Smart Home. So we need to copy and paste the skill ID into application ID field. Then we click on add button. So on the turn on light function page, we need to open the code tab section for type in the code that we needed. So in the code window for lambda function.python, we need to configure the code that we have provided below. So after we enter all the code that we have provided below, then we need to click on deploy to publish the code. So on the turn on light function page, navigate to configuration, then go to environment variables, then we click on edit. So the three environment variable will be created. Then we need to click on add environment variable to add a variable and configure the key and value fields as follow. After we key in all the things that we have need, then we click save button. So after we have create all the lambda and configure all the lambda, then we need to test the lambda function. So on the turn on light function page, we need to open the test tab section. So we select the new event and enter name for the text. For example, we type in as discovery. So we input the code. We input the following code in the code box. So then we click on save. Then we click the test button, which should return a list of connected devices in response. Then we need to configure the smart home skill, which means we turn on the turn on light function page, we need to copy the function ARN. Then we navigate to the Alexa's developer console, click on the edit button on the home assistant that we have created earlier. Then we need to open the build text section and select smart home from the left navigation bar. So we need to paste the ARN we have copied earlier in the default endpoint field and click save. After we click on the save button, then we go to the build tab section. We need to select the account linking from the left navigation bar. So after configuring the page as follow, then we can click the save on button when we done all this step. So that is all my part. Now I will pass to the next presenter.
I'm Tanjai. So now I'm going to present IoT core configuration. So first, we are creating an AWS IoT things. Then we go to service and choose IoT core. And then beside here, there's a manage. Then we click things. So we can create things now. And then we choose create single things and press next. So it will lead us to this page and then enter a name for things to be created. So we enter the OPC router. And OPC router is the central communication platform. Later we will configure it. And then we can press next. After that, we can choose the auto generate a new certificate at this page. And then we click next. So skip the optional attach policy to certificate step and click create things now. After that, it will pop up this dialog, and then we under download certificate and keys, make sure the certificate is activate. And then we can download the device certificate and then also download the private key file here. Okay. The next step will be navigate to service again and then choose IoT core again. And then under secure, we can choose policy to create a policy. To configure it, we need to type in the policy name, policy effect, policy action, and policy resource. As below, we are create the OPC router as the policy name. After that, the policy effect, we are choosing allowed, and then action and resources are all. Then we can click create. After that, the newly policy will be added at the AWS IoT core policy list. See this, just now we are create the OPC router, it will appear here. And then after that, we navigate to service again, IoT core, secure again, and then click certificates. Click on the attach policy here. Then it will pop up this, and then in the drop box option, and then select the OPC router that we created just now, and then click on the attach policy. After that, the OPC router will appear in the policy list here. Then it is successful attach the OPC router things certificate. Okay. Here is the configuration of the OPC router I said just now. So we first going to download the OPC router program, and then we open it. On the top menu, select extra, then settings. This will open the OPC router setting. On the left vertical menu, select the tab with icon as shown below here, this one. Okay, next. Certificate management section will be open, and then select the client certificates. After that, click import icon here. Okay, a file explorer window will be launched. Navigate and select the device certificate file we have downloaded earlier in the AWS console. And then the device certificate is now listed under the certificates. And then click to select it. And then click on the Add Private Key button here. A file explorer window will appear again. And then navigate to select the private key file we downloaded just now, also at the AWS IoT console. Then the private key has been added to the device certificate now. At here, there's a key. So after that, we are creating a MQTT plugin. So we go back to AWS console and then go to service, select IoT core. There's a manage here, and then we click things. Then with OPC router selected, choose the interact tab, and then we click on view setting. After that, it will appear the device data endpoint. Copy the endpoint address as shown here. Okay. Then go back to OPC router program again. On the left menu, there's a plugins button. Then we under local service, then we go to cloud or IoT. Then we click the MQTT here. Okay. Then cloud IoT, then MQTT. Then we click on the icon here, the plus icon, to plug in the MQTT plugin. Okay. After that, the MQTT window will be pop up. Under the router configuration, there's a name and cloud profile to be configured. So we type in MQTT AWS, and cloud profile we are choosing AWS. Then next, open the AWS tab. You can see the API endpoint address. Paste the device data endpoint we have copied earlier, and then after choose the existing certificate, the checkbox here, and then click the check connectivity connection. After that, it will pop up this connection established. Okay. Then the MQTT is now listed in MQTT entry list, as shown here, MQTT that we just create. After that, we are going back to AWS console to setting up the monitoring. So we're going to service and then IoT core again. And then we choose test here and then choose the MQTT test client. If it is not already open, select the describe to a topic tab here. And then after under the topic filter, we choose the enter the topic home automation for our project. Then click on subscribe. Then the home automation will be listed under the subscription here. And then we select, and it can see the incoming MQTT message here later. So that's all for my part. Thank you.
Hi, my name is Wong Hui Dong, and I'm going to presenting Grafana server on the Amazon EC2. So first, we will create an instant EC2. Before that, we will open AWS console at this link. Then we search for EC2, like the image shown here. Then we click on the instance. So after we click it, then we will see a page like this. Then we will see a launch instance here. Then we click, and it will direct us to choose an Amazon machine image. So we are using kernel 5.10, 5.10, and 64-bit. Then click on the select button. Then we will choose an instance type. So in our project, we will choose free tier, which is t2.micro. Then we click on the next button to configure instance details. After that, then we will leave it. Then we just click on the add storage. So we modify the storage size to 8 GB. Then we move on to the add text page. So in the add text here, we will configure the key and value. So the key will name as name, then the value is Grafana server. Then we click on the next to configure the security group. So the EC2 instance security group SSH22 is opened. Then we will create a default Grafana port 3000 to the internet 0.0.0/0, like the image shown here. So after that, we will review and launch. Then the EC2 instance is created as the detail shown here in the image. So after that, we click on the instance ID. Then you will see a page like this, the instance summary for the instance ID, which is named as Grafana server. Then we click on the connect button. Then we will see this EC2 instance connect. Then we click on the connect button again. Then we will go to the page like this. Firstly, we will download the Grafana in the created EC2 instance. Since this is the first time using EC2 instance, we need to update all the install packages using the command sudo yum update -y. So we will add a new yum repository for the operating system to know where to download Grafana using another command here. This is the input following code that we need to add into the repository. After that, we will install the Grafana using sudo command, which is shown here, sudo yum install Grafana. Then it's shown as now it's the installing process. So we will click Y to continue the whole installation right here. So the second progress also click Y, then here also 4, also 5. So we just move on. And then the installation complete as shown below with the red rectangle here, and shown complete. So we will reboot the system Linux to load the new settings and restart the Grafana server and also check for its status, whether the status is active or what. So we're using the command sudo system daemon reload, sudo system start Grafana server, and sudo system status Grafana server. So after that, we see the status is active. So the Grafana server is created. Then you run the sudo command here to make sure that Grafana will start upon booting the Amazon EC2 instance with the command here. Next, then we will visit the newly installed Grafana server by visiting public IP of the EC2 instance on the port 3000. So we copy the public IP here and paste here. So we will move to the Grafana server page. Then we will enter the username admin and also the password also admin. Then click login. Then we can now add data sources, dashboard users, or explore plugins and many more. That's all for my part. I will pass to the next presenter. Thank you.
Hello, my name is Bill Hansen David, and I will be presenting the next section in creating the home automation system, which is configuring the TimeStream database. So to start, from the AWS console, navigate to the IoT core page, go to rules, and click on create a rule. Firstly, we enter a name for the rule. For example, we can name it TimeStreamDB. Here, we need to write an SQL query to extract our target data variable from a source. So for example, in this query, we select the temperature and humidity value from IoT/topic, which is the name of our target topic and also our data source. And then on the same page, under set one or more actions, click on add action. Select the write a message into a TimeStream table option and click configuration. Click on create a new database, which should open a new tab where we will create the TimeStream database. Select the standard database configuration option and enter the database name. So here we name it TimeStreamDB. Then click create database. So our new database has been created, so click on it. And then in this page, for the TimeStream database, we will create a table for it. And so click here, enter a name for the table. So in this case, we name it MyStreamTable. We then set a data retention value appropriately to suit our needs, and then click create table. So we can see that the MyStreamTable has been added to the TimeStreamDB database. Now back in the previous tab, when we are creating a rule, click on the refresh icon here, and then in the drop-down menus, select the database and table which we just created. In the dimension section, we will enter these two values in their respective fields. So these will be the metadata for our time series data point. Scroll down further and select the create role button. Here we enter TimeStream role for the name and click create role. Then click on add action. And then as we can see here, the action we just created is added. And finally click on create rule. So we can see here that the rule we just created is here, and before proceeding, make sure the status for this rule is set to enabled. And next, we will be publishing some test data to the TimeStream database. So open the MQTT test client and select publish to a topic. For the topic name, we will input IoT/topic, since that is the topic that we set earlier in the SQL query. We then configure the message payloads by setting values for the temperature and humidity variable. So in this example, we set the value for the temperature 66 and 77 for the humidity. Also, we need to set the device ID. And so this payload here basically simulates temperature and humidity data captured by a sensor device. And then we publish the data. Next, we will set up time stream data monitoring with Grafana. And so as demonstrated earlier, we have already set up Grafana. So open Grafana, and from the left navigation panel, open configuration and select plugins. So from here, we search for the Amazon time stream plugin and install it. Go back to AWS because we need to create a new IAM user which will have access to time stream. So go to AWS IAM and click add users. Enter username and tick both the access key and password boxes. And also make sure to the require password reset option is unticked, and then click next. In this page, we attach a policy to give the user access to time stream. Click next again after adding the policy and skip the add tags option. And then finally click create user. So here the new user is created and we need to copy the access key ID and secret access key. Back in Grafana, under configuration, open data sources and select Amazon time stream. And then here we will add a data source for the time stream. For authentication provider, select access and secret key, then paste in the access key ID and secret access key values which we copied earlier into their respective fields. Also make sure the default region is set correctly. And then under the time stream detail section, select the time stream DB database and the MyStream table. And then finally click save and test. Next, from the left navigation panel, click the create icon and select dashboard, and then click on add a new panel. After that, a new dashboard panel will appear, and here we select the time stream DB database and its table. Set the sample query to show measurements, toggle on table view, and in the panel it will show the temperature and humidity variable created earlier, along with some metadata. So as you can see, we can use Grafana to visualize time stream data in various ways. So if we want to display the data in graph form, we just first deselect the table views and sample queries, and then next configure the following query as shown here. And so last but not least, we will be configuring IoT Sitewise, which we will also be using with Grafana. And so firstly, we will need to open the AWS console, open the IoT Sitewise page, navigate to Edge and then Gateways, click on Create Gateway. From here, we configure a gateway name. For example, we set it to Home Automation. Select Default Setup and input a core device name, and then click Next. For step 2, make sure that data collection pack and data processing pack is selected. Click Next and then skip step 3. For step 4, click on the Add Data Source. From here, set the source name, data stream prefix, and local endpoint, such as shown below. And for the destination, select AWS IoT Sitewise, and then click Next. For the gateway device OS, select Amazon Linux and click Generate. And so we see here that the home automation gateway has been added. Next, we'll need to create a Sitewise model and add assets to it. Again, open the Sitewise page, go to Build and then Models, click Create Model. And so these are all the fields and values which we will be setting up for the model. So configure the model with these values, and after configuring the model, as shown here, click on Create a Model. After creating the model, we will then need to add an asset to the model. So from the IoT Sitewise page, go to Build, and then Assets, click Create Asset. Here, select the model we just created. We will create a temperature asset, so give it a name such as temperature and click Create Asset. Here, we have just added the asset to a home automation model. And then we will then configure Sitewise data monitoring with Grafana. So like similar to the last section, we will need to create a new user and attach a policy to give it access to AWS Sitewise. Also remember to tick the boxes for access key and password, and then copy the access key ID and secret access key. In Grafana, go to install the AWS IoT Sitewise plugin and select it in the data sources section. Again, here we paste in the access key ID and secret key access key. Also make sure to select the correct region, and then click Save and Test. Then we create a new panel, and this time for data source, we select AWS IoT Sitewise, select Get Property Value as the query type, select the temperature asset, and select temperature Celsius for property. And then we can then save this panel. And I believe that is all for setting up the home automation system with AWS IoT. Thank you.